Hello, this is John Oti. This is the third part of the URS tutorial. In parts 1 and 2, we worked with writing simulations. In this part, we will go over other simulation types in varying degrees of detail and also touch on some other topics of interest. Each simulation type has a design schema associated with it. These are enumerated in this form. Here is the current state of our URS session from part 2. This session shows a hammer writing calculation. The solution states were recorded. We can transition to other simulation types under the simulation node by a selection from the simulation type box. A reading simulation will frequently follow a writing simulation. Let us select it. Because this action will drastically alter the design, URS prompts us about the danger of deleting the pre-existing recorded calculation states. Let us click Yes. As you can see in the System View window, our system configuration has changed to reflect the new simulation type. We have a shielded read head located above the same media from our previous writing simulation. The head will move over the media during a calculation. You can preview this motion by clicking the Show Motion button under the simulation node. There we go. Let's cancel out. The media magnetization does not change during the read calculation. Let us take a closer look at the structure of the read head under the Views node. We select Reader here to view the read head structure alone, and we may also select the individual reader components. Let us again display the whole design. There. The read sensor behavior is calculated using a phenomenological magnetoresistive model. You can edit its properties under the reader node. You may include or remove head pole components by checking or unchecking this box. A pole is a magnetic shield component. We edit the poles by clicking this button. This displays the Pole Assistant dialog box. In this frame up here, we indicate the pole to edit, and then we enter the appropriate data in this frame. Let's close the dialog box. Under the output curves node, we see selected the solitary output that will be plotted during the calculation of the reading process. Each simulation type has its own specific set of possible output curves. Instead of running a new calculation, let us load a read design already calculated. There we have it. We have here the reading of a pattern media. This plot is the computed readback signal for the simulation. Let us play back the calculation. We can see the read head moving over the media, and here we see the marker tracking the points of the readback plot. Let's stop the playback. Next, let us take a look at the media test simulation type. We could select it here under the simulation node, but instead we will simply start a new design and specify it to be a media test design. We go to the File menu, click New. The new design assistant comes up. We click Next, and in this page we select the media test simulation type from this box. We also select the configuration, classic longitudinal recording, from this box. Let us keep the remaining pages of the new design assistant by clicking the Finish button. And here in the System View window is now displayed the media for our simulation. The media test simulation would typically be used to study bulk media behavior. Because one can readily transition to other simulation types using the same media, this greatly facilitates the correlation of bulk behavior with system properties. We see under the simulation node that for this simulation we can specify vector external magnetic fields that may be applied to the media. The writer and reader node input areas are disabled as they are needed for a media test simulation. The thermal source node is relevant once a thermal source is activated. This provides the means for subjecting the media sample to temperature variations during calculations. We can edit the media under the media node, and we can include an underlay. Let us load a pre-calculated media test design example. Here we have it. These plots are the computed media magnetization curve components of the sample. The calculation states of the design have been recorded. Before we take a look at those, let us display the external field panel from the simulation node. There it is. The field panel displays a three-dimensional vector plot of the applied field. At the recording and playback node, let us first jump to a convenient solution state. Done. Then let us play back the calculation. Back here, we can see the playback showing variation in all the open windows. Okay, let us stop the playback now. Briefly, for the next two simulation types, the right field and media field scans, a moving field probe senses and plots field strengths around right heads and recording media. The final simulation type we consider, the right and media field scan, combines the concepts of the previous two. This simulation plots the combined field of the right head and media. Let us load a pre-calculated and recorded example of such a simulation. Here we are. In this design, the auxiliary and main poles of the writer are positioned on the same side relative to the media. The media is a composite one consisting of a pattern storage layer and a shield underlayer. Let us play back the calculation. Here we go. If we look at the view from the top, you may notice that the probe is actually moving at an angle to the media. And with that, we come to the end of part 3 of the URS tutorial. Here is a recap of what we have learned. Hopefully, we have given you a good feel of URS in these tutorials. The software offers a general purpose modeling capability. It is really up to your imagination what you can do with it. Refer to the context-sensitive help feature, user manual, and our web resources to learn more about using the package. Thank you.